Let me take up the next question. The charge given to any conductor resides on its outer surface because option A, the free charge tends to be in its minimum potential energy state. Option B, the free charge tends to be in its maximum kinetic energy state. Option C, the free charge tends to be in its maximum potential energy state. Option D, the free charge tends to be in its maximum kinetic energy state. The answer is option A. The free charge always tends to move on its outer surface because on the outer surface the potential is going to be minimum. It tries to occupy the minimum potential surface, so the charge will tends to move on its outer surface. So the option is A, that is the answer, option A. Take up the question number 9 in page number 569, book number 4. Two identical conductors of copper and aluminium are placed in an identical electric fields. The magnitude of induced charge in the aluminium will be option A 0, option B greater than in copper, option C equal to that in copper, option D less than in copper. Both copper and aluminium are metals, so they induces the equal amount of charge. So the option C is the answer. So whatever the induced charge is taken place in the aluminium, that should be equal to that of copper. So the answer is option C. Then coming to the 10th question, two particles of equal mass m and charge q are placed at a distance of 16 centimeter. They do not experience any force. The value of q by m is 1. Option B, root of pi epsilon naught by g. Option C, root of g divided by 4 pi epsilon naught. Option D, root of 4 pi epsilon naught into g. Now, if the two charges are placed q, they are separated by a distance of 16 centimeter. If this is not experienced any force, in the sense the electrostatic force what it is going to experience should be balanced by the gravitational force. So the electrostatic force between these two will be equal to 1 by 4 pi epsilon naught into product of the charges, that is q square divided by the distance square, that is 16 square. That should be equal to the gravitational force between the two charges having some mass, that is nothing but some g into masses of the particles, that is m into m divided by the d squared, that is 16 squared. 16 squared cancel out. So the q squared value is equal to 4 pi epsilon naught into g m squared. So value of q equals to root of 4 pi epsilon naught into g into m squared. They are asking to calculate the value of q by m ratio. So q equals to root of 4 pi epsilon naught into g, root of m squared becomes m, or q by m is equal to root of 4 pi epsilon naught into g. Answer is D, root of 4 pi epsilon naught into g. Also there is a relationship between q, m and g. The ratio of q by m is always directly proportional to root of g. So the option q by m always goes in terms of root g. In the given option, in only one option there is a root g, that is in the fourth option. So D is the correct answer, that is root of 4 pi epsilon naught into g. Let me take up the problems on electric field lines and dipole. There is an electric field E in x direction. If the work done on moving a charge of 0.2 coulomb through a distance of 2 meter along a line making an angle 60 degree with x axis is 4 joule, then what is the value of E? Option A 3 Newton per coulomb, option B 4 Newton per coulomb, option C 5 Newton per coulomb, option D 20 Newton per coulomb. in this problem, there is a certain amount of work done in moving a charge from one point to the another point, that is moving in a direction at an angle of 60 degree with the x-axis. In that x-axis direction the electric field is acting. For that the amount of work done that given as 4 joule and the charge is 0.2 coulomb, it is moving through a distance of 2 meter. So, if this is the electric field direction, the charge of 0.2 coulomb is moving in a direction making an angle of 60 degree to a distance of 2 meter. They are asking to find out, to calculate the value of electric field E. In order to move this charge from here to here, the amount of work done that given as 2 joule. The amount of work done that given as, the work done is nothing but the basic definition, the force into displacement. The force into the displacement should be in the direction of the electric field. So, this 2 meter can be split into 2 components. This is 2 cos 60 and the perpendicular component is 2 sin 60. So, the displacement taken along the direction of the electric field is 2 cos 60. So, force into 2 cos 60. Work is equal to the force experienced in the electric field is given by the formula Q into E. 2 cos 60 is 1 by 2, 2 to get cancelled. The work done that given as 4 joule. And what is the charge that given? 0.2 into electric field. So, electric field is nothing but 4 divided by 0.2. So, the electric field is 20 Newton per coulomb. So, the option is D, 20 Newton per coulomb. Coming to the next question, a point Q lies on the perpendicular bisector of an electrical dipole of dipole moment P. If the distance of Q from the dipole is R much larger than the size of the dipole, then the electric field at Q is proportional to option A, P power minus 1 and R power minus 2, option B, P and R power minus 2, option C, P squared and R power minus 3, option D, P and R power minus 3. In this question, it is based on a formula. The electric field on the equatorial line of a dipole is nothing but 1 by 4 pi epsilon naught into P by R cube when R is very much greater than A. As the formula tells, E is proportional to P and it is inversely proportional to R cube. So, we can write E is proportional to P by R cube, or E is directly proportional to P power 1. When R power goes to numerator, it becomes R power minus 3. So, the electric field at a point on the equatorial line when R is very much greater than A is directly proportional to dipole moment and it is directly proportional to R power minus 3. Therefore, the option is option D, P and R power minus 3 is the correct answer.
CHIPS proudly announces admissions for crash course for JEE mains and CET coaching. Classes commence after 2nd PUC and 12th board exams. Crash course for 2nd PUC regular. Classes commence after 1st PUC and 11th board exams. Accommodation assistance provided for outstation candidates. Centers at Kumta, Dandeli and Bangalore.